Welcome everyone. Last time we spoke about payment IDs and integrated addresses, and this time we will talk about a use case and a practical infrastructure that you could use in your production. So a customer visits your site and he sees a price, has an ID 1 and wants to become a member. He clicks on the button, become member. On the next screen he will see an address and a text that says, okay, if you want to become a member, pay 1 Monero to this address. The next screen will be a loading screen. The server is waiting for the incoming payment. And if he receives the payment, he will show something like done. Okay, I guess this is very intuitive and nothing new so far. But let's talk about what has to happen in the back end for each of those steps. At the first step, there has to be something like a request for an address, because if you click on become member, of course you want to have a new address. All right, because we see in the second step an address, we have to have something like an address as an answer. Good. In the third step, it gets a little bit more difficult because multiple members clicked at this button at the same time, on this button on the same time. And they don't pay in the correct order in which they clicked on the button. So yeah, you get a payment each second, or for example. And this is where you need integrated addresses of a last part. So this step involves, of course, something like a circular check in the blockchain if new incoming payments arrived. And for this check, you need something like the payment ID of the last video. So, but this means also that in this reply here, in this reply, you also got a payment ID back. So you got an address and you got a payment ID. And this address that you got here, the 4L address, is an integrated address that includes this payment ID. So the customer includes this payment ID also to its transaction, so it's visible in the blockchain for someone who has a BU key. So we have to have something like this, payment ID that resolves to the member ID. And now step 3 is quite logical. If an incoming transaction fits to the payment ID or uses a payment ID, the screen with for the member ID gets an event which looks like this and says done. Yeah, this done event is triggered by this component. Okay, so now we thought about our API calls. In the next step, I want to talk about the components that are behind each step. So let's start in the beginning again. Here, we have to have something like a component that is able to calculate addresses and payment IDs, and of course answer requests for this, so it has to have something like a REST API. We have to have something like a key value store, a database that stores the payment IDs and the member IDs that belongs to the payment ID. We have to have something like a circular checking mechanism of the blockchain. And this checking mechanism has to trigger the done event. So it has to have a trigger that triggers the done event. Payments are a little bit critical because if something runs wrong or get hacked, someone will lose money. So we will discuss what are the absolutely minimal requirements for each component to make it as safe as possible. first, for the blue component, you need the public key for public spend key and public view key. And this could be offline because you need no interaction with a blockchain or something like this. And you need something like a random number generator for the payment ID, but yeah, not that critical. So no sensitive information, those are public keys, and it can be offline, perfect. Next step, the database. The database also offline, and there are no sensitive information in it. It stores no sensitive information because the payment ID, if someone else gets a payment ID, he's able to send money to another member or pay the membership of another member, which is not that critical. So it's not as critical as a private key or something like this. The yellow component requires first time a private key, the private view key, because it has to check for new incoming transactions that belong to the corresponding public keys. And it has to be connected, go scroll a little bit to the side, to the blockchain. So it has to have access to the blockchain. Okay, so the yellow component is a little bit more critical. Yeah, I feel based on a feeling, but again, I have to make a focus on I have to mention that no private key is involved, no private spend key is involved. If you compare this to the Bitcoin network, where the generation of a new address requires generating a new private key, which has to be stored somewhere. And if someone gets the private key, all your money will be gone. This is not necessary in Monero. So in the next step, we will see how to set up an infrastructure completely without a private spend key and completely without the possibility to get hacked and lose a lot of money. Even if an attacker would have something like root access or something like this. Of course, well, that's not true. If an attacker has root access, he could send own integrated addresses or stuff like this. So he could there could be some kind of damage, but he's not able to get your money that is also theirs, and this is a benefit. Okay. You created your well-known keys, your private keys and your public keys, and of course you will send only the view key and the private view key and the public keys to the server, so your spend key remains safe on your hardware wallet wherever. And what you will do on your server is you will import these keys or this private view key with a command line tool, Monero Wallet CLI, and create a view-only wallet. This view-only wallet will be used by the program Monero Wallet RPC, just to make it accessible to your backend code and stuff like this as with an RPC. And I will cover this shortly. So one of the main methods is make integrated address. I will link those the documentation for this in the video description. And the second method is get transfers. So as you might expect, the first method is for creating, I can mark it blue like in the last slide, is for creating the address and the payment ID. And the get transfers part is basically this repeatedly checking for transfers. A short tip from my side, you can specify just to check for incoming transactions, and you can also provide something like min height. I mean, just in case you shouldn't scan the whole blockchain again and again, or in fact you don't scan the blockchain, but you shouldn't get all your payments and look for the new one. Yeah, just do it for the last blocks, and if you check the block, you don't need to look at it again. This will scale much better if you use these arguments. There are so many other arguments you could use. For example, you could protect the access with integrated private key checking or certificate checking of clients that want to access wallet RPC, or you can just offer some methods or something like this, restricted RPC or something like this. It doesn't matter that much because because this band key isn't on your server, so it's safe anyways. But you can protect it even more. This wallet RPC will talk to your Monero daemon. This is the program called Monero D. Oh, there's an R missing. And this is what downloading the blockchain and so on. This could be also on another server if you want this. If you have something like, maybe you could have space issues, but you could use something like the argument prune blockchain. This will save a lot of storage and is not that important if you are just using a view-only wallet. It just wasting the decoys in transactions, which saving a lot of space. But since you don't want to pick random decoys, it's not important. You only want to check for incoming transactions, and you don't need them. Again, you can protect this Monero daemon with TLS in almost any way, and you can password protect it and offer just a few things, and you can also say your Monero wallet RPC that you are using an untrusted daemon if you are connecting to a public Monero daemon because you don't want to download the blockchain and you're operating on a small VM or whatever. Of course, you also need something like a database of your choice. Pick one that feels good for you. Something like Redis with storage on, whatever you would like. MySQL, I don't know. And that's basically it. I hope you enjoyed the video. Let me know if you want to see more practical videos or more theoretical videos or both. See you next time.